traffic flow theory, we went through these relationships. Okay, we looked at this example. Okay. So in the previous example, we had a case where we had these two lines. So somebody remembers what are these two lines?
The horizontal line, the straight one, is the capacity of the street, and this the flow during the time.
Demand, not the flow. Demand. Okay. So what happened? Demand went above capacity. So we calculated three things here: length of the queue, clearance time of the queue, and the delay, total as well as average. Okay. This phenomena which happened here, demand going above capacity, it is called as a breakdown. Okay. So when demand goes above capacity, what do we call it? Now, if we have, for example, 500 vehicles on the road, and the capacity of the road is more than 500, will you have a breakdown? No, right? When, so these vehicles are moving on the road. When a breakdown can happen? So these 500 are 500. They are not changing. So when a breakdown can happen?
External.
Yes.
Okay, accident.
Sorry. Intersection, right? Because in intersection, other vehicles can also enter. Okay. So the breakdown will happen if we have mainly two flows merging into a highway. People from two different directions or two different highways are not coming together. Okay. One highway itself cannot have a breakdown. You understand? Okay. I have a box. That box has a capacity of 1 cubic meter. It will remain 1 cubic meter. Okay. If the box is closed, I know inside the box is 1 cubic meter or less. It cannot be more, right? Okay. Only when I open the box, then I can try to put something more in it. Okay. And then I can go above the capacity. I may try to put 2 cubic meters in it. Okay. So until the highway reaches a point where external flow can enter, okay, then there will be no breakdown. Unless an external flow enters and tries to break the down. Got it? Okay? So demand goes over capacity, it's a breakdown. So when can it happen? When two flows are trying to merge into each other. And when does it happen? Intersections? Very common, right? People are coming from here, from here, from here. Okay? Then we have on ramps. So there are already vehicles on the road. Maybe these vehicles are below the capacity, but now there are 1,000 more trying to enter. So this plus 1,000 is above the capacity. So breakdown will happen. Okay? And same thing with the merge point. Okay? What is the merge point? This thing. This is the merge point. Okay? This is a highway. This is a highway. Merging. Okay. So now you can see how the breakdown is happening for each highway. They have given capacity, demand, and volume. So capacity is 4,000, demand is 3,800. Okay? Any problem? No. So the volume is same as demand. Okay? Here, capacity 4,000, demand less than capacity. No problem. The volume is okay. Now demand for this one. This road is taking demand from where?
These two.
Okay. So this demand and this demand will adding. Okay. So this demand plus this demand is 7,400. The capacity of the road is 6,000. So what will happen? What did we call that? What did we call it? A break. Okay. With the breakdown, you will have the queue, and where the queue will happen at the entry, basically. Because from this point onwards, they become restricted. Up to this point, they can come, right? The volume is less than, demand is less than capacity. Up to this point, they don't have any issues. The issues start where both of them try to enter into this one. Okay, clear? Okay. So yes, it's an example of merge point. Now here you can see volume equals to what? Capacity. Because demand was more than capacity. Here volume equals to demand, because demand is less than capacity. Okay. So normally demand is either equal to, volume is either equal to demand or either equal to capacity, whichever is low. Okay. Clear? Okay. Another example. This is for the ramp. This example is for the ramp. Okay. So I have a highway segment, after which there is an entry ramp, then another segment, another entry ramp, another segment, then an exit ramp, then next segment, exit ramp. Got it? How much flow already on the highway? This much. How much is entering from here? This much. Okay. How much entering from here? How much wants to leave from here? This much. How much wants to leave from here? This much. Fair? Okay. So these are all demand values. Capacity of each segment. A ramp do not have a problem of capacity. Assume. Okay. So the only problem which can happen is on the highway itself. So what is the capacity of each segment of the highway? It's given here. Okay. So all segments do not have the same capacity. Less, more, less. Okay? Okay. Now, demand, capacity. What is the volume? Segment 1. 2001, right? Okay. Any problem? Next one. This one. 3000. Why 3000? He is not letting me talk. He is on auto mode. Yes. Still 3000. What do you mean still? It was 3000. It became 3000, right? Yeah. Yes. Okay. Huh? It changed, right? It was 2200. Changed to 3000, right? This is what all of you agree, right? Segment 2, 3000. Okay. Why 3000? Because you have 2200 already. Okay, plus 800. So this one will be 3000. Okay. If this does not erase, you will not tell anybody that I did it. Okay. You are doing 2 courses with me and a second. Okay. This much is clear or not? Next one. Next one is written 3001. Okay. Is 3400 equal to demand or equal to capacity? It is the capacity, right? What is the demand? 3,010, right? Anybody have any problem with that? No problem? Okay. Yes? There it is. You are saying that's the problem? Yes. But you don't have the problem in understanding why this is 3,400, right? Yes. Forget about these. Don't have a problem, right? That's good. Okay. Now, next segment. 2941. How? Why?
Because of 3,400 minus 4.5.
Uh,
Less than the demand. So we have a Q on this side.
no, it's, okay. Okay. Let me rephrase the question. Okay. This is 459. This is very obvious. They were 3,400 minus 459. It became this. Very simple logic, right? This much is clear. So the problem is not here but here. Why this? Okay. So my question was wrong, right? Now imagine I will make your exams. And my questions are wrong. So why 459? That's the question. Yes.
We have a Q here because the demand is larger than the capacity. So according to the Q calculation and things and the time, that's what happened.
See, now she said this without realizing what calculations have to be done.
Didn't?
Okay? And those calculations will come in the exam. That's right. See, now he's trying to simplify. No, it's not this. She already said it. It's in my head now. And don't worry. That's very easy. Okay? It's very easy. 3,400 actual volume, 3,700 demand. Okay? Their difference is blocked here, right? I said the problem comes at the entry point, right? The problem is here. Okay? Out of 3,700, 500 were going out, right? So this 500 was part of this. This 500 was part of this. So if I stop some of them, then some of those 500 are also stopped. If out of 3,700, some of them are stopped here. Okay, so from those some, there were people who wanted to go from this line. Clear? Okay. Now the problem is how much? How much of this 500 did I actually block here? Okay. So how much is out of 3,700? I allow 3,400. So rest are blocked, right? So I can calculate the ratio. Okay. I can calculate the ratio. How much is this? 91 point. Yes. Okay, so the actual demand carried forward is 91.9%. Okay, so the actual demand which will carry forward from the ramp will also be 91.9%. Got it? Clear? Okay, so this 459 is 91.9% of actual demand. Clear now? Okay. So it was 500. We calculated how much is actually going forward from the demand. Okay, and we got 91.9%. So 91.9% of 500 is 459. So it was 3,400 in this segment. 459 went outside. The remaining comes to the next segment. Clear or not? So this 2941 is 3,500 minus this. Okay, and this one is 500 multiplied by this. Where? Sure. Everybody. Okay, the next one, same rule. The actual was 400, but some of them are restricted. So this 368 is what? How do I get 368? 91.9% of 400. Okay. So 91.9% of 400, 368. It was already 2941, 368 went outside, eliminate. Okay. Any problems? Any questions? Okay. Now, which segment started the problem? Tell me. Segment 3. Segment 3 is what we call as a bottleneck. Okay. Segment 3 is called as a bottleneck. And whatever you see forward are the effects of bottleneck. Right? They are the effects of bottleneck. So bottleneck is the name of the segment, type of segment. And what is happening in this segment is called breakdown. Remember. Okay. So bottleneck is a segment where breakdown happens. Demand goes over the okay? Let's say somebody, no, before that, this here we had segment 1, we had 2200, right? Okay, 2200 is the demand, right? So the volume is equal to demand. Okay, next one, 3000. 3000 equal to what? Which one? Demand or capacity? Demand. Okay. 3400. Is it equal to demand or capacity? Capacity. Okay. Next segment we got 2941. Is it equal to demand? Is it equal to capacity? Is it less than capacity? Yes. Is it less than demand? Yes. Right? So we are not fulfilling the demand and we are not reaching the capacity as well. This is called as demand starvation. What you see in segment 4 and 5 is called demand starvation. When the actual flow cannot reach the demand and cannot reach the capacity as well. It is lower than both of them. Okay. Why demand starvation happened? Because of what? Sorry? No, you are telling me what is demand starvation. I am asking why. Why volume became less than capacity and demand both? It was not happening up till now. Right? It only started after what? Segment 3. Segment 3 is what we call? Bottleneck. Okay, so after bottleneck this can happen. After bottleneck this can happen. Because bottleneck is not letting the true demand pass. Okay, so obviously the demand which will reach the next segment will be less than the actual one, right? Because it's already in. Okay, got it? So after the bottleneck you have demand established. Okay, you may observe it when you are passing through a highway, there is an accident. So you are stuck for 10-15 minutes. After the accident, you see a clear road. Even less than the normal. Why? Because everybody is stuck before the accident. Clear? Okay? Any questions? Okay. Now let's say in this case, the government decides this segment is a bottleneck. Let us increase the capacity of this segment. Let us add a lane here. So they add a lane, the capacity becomes more than 4,000, whatever, but it's more than 4,000. How much we actually need? Yeah, no problem. So if 3700 is the volume in segment 3, what will be the flow out of the ramp? 500. Okay. The actual demand, right? Everybody is passing on. And what will be the volume in the next segment? 3700 minus 500. So how much will reach here? Huh? 3700 minus 500. 3200. But now, see a problem? What's the problem? Yes. Now this segment has the problem. You shifted. Okay. So what segment 4 became now? About okay. It was hidden because of demand starvation. Its actual demand was less than or more than capacity. The actual demand of segment 4 was more than capacity. But because of an earlier bottleneck, it had demand starvation. Yes. Which one? Huh? This one? It was actually 400. Okay, it was actually 400. Okay. But some of the flow was restricted here. So we calculated how much flow is actually passing from the demand. Demand is 3700, out of which 3400 is passing, right? So the ratio is 91.9%. Okay. So this 368 is 91.9% of 1. Right? We calculated how much of the demand bottleneck is passing. Wrong glasses. Okay, clear. Yes, sir. Clear. Okay. So where was I? Yeah. I was saying that the actual demand is more than the capacity. Okay. But it did not reach this value as well because of the bottleneck earlier. When you remove that bottleneck, now you discovered another bottleneck. Okay. So this is discovered only after removing this, right? If I did not remove this, if I did not solve the problem here, the volume is even less than the capacity. Okay. So this type of a segment is called a hidden bottleneck. Okay. A hidden bottleneck. What was happening in segment 4? Volume was 29 something, right? So what did we call it? What is this? No. This thing which is happening in segment 4. Demand starvation. Okay. So segment which has demand starvation could be a hidden bottleneck. So you have to look at the actual demand and the capacity. Not the current volume. The current volume could be less than capacity because of demand starvation. Got it? Okay? So, demand goes above capacity, breakdown. Segment where demand goes above capacity, bottleneck. Okay? Bottleneck causes other segments to have demand starvation. Okay? Maybe because of demand starvation, the volume went below capacity, but the actual demand was above capacity. Okay, so the segment in which this is happening, we call it the hidden bottleneck. Okay, the hidden bottleneck is where the demand is over capacity, but it is having demand starvation. Okay, because of demand starvation, we see, look at the volume, so okay, 29 something. incident. Last year, they opened a lane near IKEA, okay, for going towards that thing, going towards when you are taking the exit near IKEA from the highway, okay. So they opened another lane, okay, and they opened another lane near Z town. When you are coming on from the other road to the highway, they opened an extra lane here and an extra lane there, okay. Before they opened these lanes, the highway was open, okay, because people are getting stuck on those lanes, okay. When they opened, especially the lane which is coming in from that town, okay, the extra lane, now more people are coming in. So earlier the traffic jam was here. People were getting stuck on the entry. And they opened the lane. Now all these people are coming in and now they are getting stuck on the highway. Okay. Doesn't happen always, but in the peak hours. Okay, so when you are making these decisions, you have to keep in mind what will happen to the next one. How much is the actual demand? You need to keep in mind the actual demand. Okay, not the one which the segment is showing right now. I showed you a slide last lecture. Some people know about traffic jam and they change their plans. So if one of those people heard, okay, now we have a new lane. So I was going from the other highway, why should I waste my time here? This highway is much better now. It's bigger, let me go from it. Right? Okay, so you have to look at the actual demand. Okay, these are some of the examples which you should look for, solving in practice and so on. And the examples which I showed you are from two different editions of the book. Okay, I uploaded both of them. So they are covering the same topics basically. Okay, the next part of the course is about traffic data collection. This is chapter 9 of the textbook. Okay, so when I am referring to the chapter number, I am referring to the new edition. Okay, both of them are uploaded, but the chapter numbers are according to the new edition. So we are covering this silo where you try to get the ability to collect traffic data and analyze it. So we will have next few chapters dedicated to this side. Okay. So for a highway system, when we have a system of highways, network of highways, we want to know the current state of the system. Okay. The current state means how many lanes we have, how many signals we have, where we have the breakdown, which segments are bottlenecks, and so, okay. The thing which you were asked. I told you, right? This highway has a problem, this highway has a problem. Okay. So this is part of knowing the current state of the system. Okay. Like what is the current performance of the system, where we are having the problems. Okay, and what is the system actually? Okay, where we have small streets, where we have major highways, speed limits, design, speeds and so on, where we have the curves. Then we have, and we also need to know the current demand of the highway. Now, see, they are saying demand, not volume. Okay, volume can be calculated, but demand is the actual issue. Okay. So the current demand as well as the future demand. The highway specialist, a traffic engineer, has to know about these things. Okay, about their highway network. The current state, the current demand, and the future demand. Future projection means how much it will be in future. Yeah. Okay. When you start collecting the data, you need to make sure that you know or you establish your objectives from the start. Okay, you establish your objectives from the start. You know from the start why I am collecting this data. Because based on your objective, your method can change. Okay. In the last lecture, in the last topic, we talked about two types of mean speeds. Which were those? There were two types of mean speeds. Huh? Average mean speed and average mean speed. Right?
Spot mean speed and time mean speed.
Say again.
Spot mean speed and time mean speed.
Close enough. Space mean speed and time mean speed. Their equations are different. There are different values required for them. So if you did the survey, oh, we are doing speed survey. Let's go and do speed study. Bad. Let's go and do speed study. Then you don't know why you are doing it. Whether you need space mean speed, whether you need time mean speed. Okay? After you collect it, you may come up with a value which you don't even need. So your entire effort and time is wasted. Okay? You're saying speed, which is speed? Huh? Whatever. Okay. So the point is, you need to save your effort and you need to establish objectives in advance. Another thing which you have to keep in mind is, what do we mean by traffic in modern day? Okay. When you hear about traffic, what comes to your mind? When we say traffic, what comes to your mind? Yes. Huh? Yes. There's too much traffic on this highway, so they are thinking too much what? Too much vehicle, right? Okay. This is what we call the traditional view of traffic. Okay, or the view of traffic which the others are thinking about. Traffic engineers are not looking at it like this. Okay, for traffic engineers, traffic is basically the users of the highway system. All the users of the highway system. Okay, those could be the people who are on bicycles. Those could be the people who are just walking. These could be the people who are just sitting, passengers. They could be in the buses. They could be coming from somewhere on a plane. Okay, so they will come and then they will join. Okay, so modern purview of traffic includes all road users. Okay, and we know all road users cannot be at the same place at the same time. You cannot let a pedestrian cross while the cars are moving. Okay, so when we say all road users, then each one of them may have their own space on the road, dedicated space. Okay, like a sidewalk or a pedestrian bridge. Okay, so a traffic engineer has to look at traffic from the perspective of all road users. Okay, and where will they be on the highway? Clear? Okay, so you need to know these things. When you are doing the survey, establish your objectives, and you need to know what do we mean by traffic. Okay, in terms of traffic engineering. Okay, when we come for data collection, our life has been made much easier. Okay, last year at the end there was a conference, I believe November or December, and there were a lot of people who were presenting in that conference. I was there as the chair of that session. And there were a lot of people who were coming and presenting about electric vehicles, autonomous vehicles, driverless vehicles, and so on. And from where they were coming? India or some other country like this, where they don't even have this. Okay. But the data is available. So that guy has access to the data from US or UK. Okay, like we have access to the data which is from UK, 5 years, 6 years of road crashes. Where it happened, how it happened, who was involved, everything. It's available. You can go and search anytime. It's downloaded. Okay? And it's not about one country, it's about many, many countries. Okay? One example for this region, you have King Fahd Palace. Okay? So I don't know whether they are still doing it or not, but they have cameras installed on the causeway, like at very other high actually see and count. If you don't have anything else in your life, you can sit in front of that camera and you can count how many cars are going from each gate, and you can take measurement. Okay, the next car comes after 2 minutes. The next car comes after 1 minute 30 seconds. Get my point? Okay, so the data availability has increased. Okay, in many cases the data is readily available. Okay, so what are the sources? There are online sources available. The link given. Okay. Then another type of data which is available through the devices. Data is collected. You may have heard about this conspiracy theories, right? They are watching us and things like that. So our devices are recording the data continuously. Okay. There was a research I saw in which you go to a place and you do check-in on your Instagram or something, right? And you take a picture and you tag, I was here. So data is there. Okay. Anybody who can do a query, you know the meaning of query. Like what you do in Excel, find. So it can find how many people were there on this day at this time. How many people actually posted about this place on this day and this time. Okay, the data is there. Okay, like somebody has to just sit and gather it, collect it. Got it? There. So these devices include your phones, your social media apps, okay, even the laptop maybe, I don't know. Okay. So there are these devices which are regularly collected. Some of these devices are installed on your cars, okay, for safety purposes. They are delivery trucks. They have devices installed in their trucks. We have buses, right? The bus system in the bus company by you can actually track the bus real time. You can see the app where is it, how far is it. Okay, 5 minutes, 10 minutes, whatever. So how they are doing, they are trackers which are installed in the vehicles. These trackers are taking the data. Okay. So we had access to delivery company data from Europe. So it had the data from all over Europe. Okay, like it had data from the roads which are not really even shown on the map. Because maps need to be updated, right? The car is going on this. Okay, so much data was there. Okay, so they have data available for devices which are installed on the cars, devices which we are carrying with ourselves, and the data which we are posting ourselves. Okay, so all this data is available. It just needs gathering. Okay, somebody has to sit and okay, I need the data for this speed only. You can take it. Okay, you can have it. But the problem is what? Anybody can take this data? No? Who? Authority, right? Not all these authorities take it or not? Do they take it or not? Do they take this data or not? Yes? Okay. So they know very well, right? Usually they don't. Okay? Because there are privacy issues. They need, even the authorities need special permissions. There are privacy issues. We tried for a research project to get a device which can like track how many people are going from the highway using their phones. Okay, like the signals which are coming from the phone. You couldn't get the privacy issues. Okay. Then we have traditional approaches. You go to the site, you collect the data yourself. Okay. Okay. So in these cases, there are some equipments which are portable. So you can just like put them on the road, they collect the data, and later on you carry them with you. Okay. These are called portable equipments. Equipments which can carry with you, so they can collect data real time for short periods. Okay. Some of these include these. No, not this. Yeah, one of them. Okay, these are called as pneumatic road tubes. Okay, and they are sometimes they have counters which are mounted on a pole. So they put it on the side of the road, and there's a counter and it is taking the data. these some of these devices are portable. This one, pneumatic road tubes, they use it very commonly in barring. Okay, so anytime you see a black wire going across the road, it's a pneumatic road tube. So they put it there for traffic data collection. Okay, it's a very common practice in barring. Before any project, they do this. You collect real data just before the project. So we have different types of counters. One of them I already showed you, the wires. Okay. Then you have counters which are on the pole side of the road. Okay. You can have counters which are installed under the road as well. Okay. But obviously they are permanent. These counters are permanent. Okay. Let us put it under the road and we will come after 2 days and dig it again. Okay. These are permanent counters. Okay. Then we have video measurements. You take a video, and from the video you get the data. You can see the number of cars, right? You can take their timing and so on. Okay. So how many times they change the lanes and so on. I will talk about the devices. Okay. These things are what we call as hand counters. Okay. These are called as hand counters. Okay. You go to the site, you are counting, you need something to note it down. Right? Okay. So these hand counters are for noting down the numbers. Instead of doing it on a paper, you can use one of these. Okay? So you card passes, you press the button, card passes, you press the button. Okay. This one is digital. Okay. Now they came up with it something like this for the Zikr as well. Okay, on the apps. Okay, so keep on clicking and you will count it. Okay, so this is similar to that. But the good thing is, in this case, you can see the movements. Okay, so the car is going here, I will click here. It will add one here. The car is taking a right turn, I will add one here. Okay, you can do it here as well, but then you have to specify it yourself. Which button is for right turning, which button is for straight and so on. Okay, so you can do multiple counts at a time. Okay, once you collect traffic data, where can we use it? You can use it for repair and maintenance work. When you collect traffic data, we know which roads need maintenance, and when should the maintenance be planned. Okay, and so we try to plan it where it will cause less problem to traffic. Right? Okay, you may see a lot of places they start working at night. Not now, this is not now. You gotta wake up at night. So, but in normal days. Yeah. We want traffic data to establish trends of traffic growth, traffic increase. Okay. So if I ask someone what will be the traffic after 20 years, how will he know? How will he or she know? He will look at the past data. Okay. So in 2 years, traffic increased by 2%. Okay. So every year increasing by 1%. After 20 years, I can tell you this much. Got it? Okay. Well. All right. Everything all right? Okay. Understanding travel behavior. When you collect traffic data, you know how the drivers are behaving. Like you guys already know how you guys behave, like for other people. Okay, what is the normal speed? We're talking about 95th, 85th percentiles, right? So, how do they know that drivers go like 85th percentile generally? Okay, and there are other things which we can why or how far from the intersection the drivers start to change their lane. When they stop on the intersection, how much spacing they keep between themselves. Okay, so these things. These are all related to drivers, right? Related to driver behavior. In the last topic, we did some derivation, right? We grabbed some equations. Equation the straight line, then flow density, flow speed, right? Those equations. Okay. But we started with the straight line. To plot the straight line, I need data. So calibration means derivation of the equations. But derivation cannot happen if you don't have the data. Okay. The starting point of derivation is data. Okay, then we have the effectiveness of improvements. So you did some road work, some repair work, or maybe you installed a new signal, maybe you changed the radius of the roundabout. Okay, what happens after that? Can you just leave it? Okay, I did my job, now I don't care. No. Once you have done your changes, you do a short survey to see what are the effects of the changes. Okay, we call it a follow-up history. Okay, that is called a follow-up history. Then we have the effects of future developments. So this is effects of development which already happened. Effects of development which will happen in future. So the government is planning that we will have a new housing scheme here, a new compound here, a new mall here, okay, or a 20-story building here. So after this is constructed, what will happen to the highways? Okay, so you cannot be behind. Okay, let us construct it, then you will see. No, then you are too late. You have to start planning for it from now. Okay, so now we have new schemes. There are Marak and the new Sutra Island and blah blah, right? Okay, the government already in their plans have what we are going to do with the highways in those areas. Okay, so but for that we need the traffic data, the whole traffic data. And one of the most important things now is air pollution. Your facility will cause traffic. Traffic will cause pollution. How much? Okay, so you need to control it. Okay, then the last thing which I already mentioned, okay, in the first slide as well, knowing the performance of the current system. Okay, traffic jam, delays, travel time, nominal speed. Okay, these things. Okay, these are called the performance of the current system. Okay, these are the studies which we do for traffic. Okay, we will go through them. So let us start with volume. Volume we covered in the last chapter as well. How do we define volume? Volume is what? Meters per hour, right? Meters per unit time. Okay. So if demand increases, volume increase, right? Volume will increase. It may not reach the same value. We saw it in the example, right? It may get stuck at capacity, or it may get stuck below capacity. But the trend is what? If volume increases, demand increases, volume will increase. Okay. So we use volume. I told you in the first chapter as well. We use volume for planning, for design. Okay. All of our design is based on volume. Okay. And the design can be for highways, it can be for signals, it can be for anything related to traffic. Then we have speed studies. Speed studies are the main input for road safety. Okay. So you want to see if this road is safe or not. What is my standard? The speed at which the vehicles are moving, is it less or equal or more than the design speed of the road? If it is more, you will have accidents. If it is less, fine. Okay. If the drivers are over speeding, you may see many crashes there, many accidents there. Okay. And the speed affects the crash or the accident in two ways. When you are going at high speed, your chances of error is higher because you have less reaction time. Okay. And if you have a crash, then the damage will be higher. The speed can cause the crash because you are over speeding. It can increase the chances of the crash, and it can also increase the severity of the crash. So when we are setting up the speed limits, we do a speed study on the or similar roads to find out what is a good speed limit. Okay. Important point about speed and speed limits is you need to keep in mind the expectation of the driver. Okay, if you are blindly setting up the speed limit, okay, we have accidents, let us reduce the speed limit. You will not have the same effect. And you have to put the cameras, right? Then everybody else, an engine. But the thing is, if your speed limit is matching with the driver expectation, you will get better compliance from the driver. They will try to follow the speed limit, okay, because they can see that this is what it should be. Okay, then we have travel time studies. Travel time studies are mainly used as a performance measure. Okay, a highway is good, a highway is bad. If I go from here, it will be good. If I go from here, it will be bad. You are deciding on the basis of what? Travel time. You are not counting cars. You are not looking at the pavement cracks and these things, right? You are looking at what? Travel time. Okay. Some of us will go from the ground and over the median and over this and that just to save time, right? Okay. So our main thing is time. Okay. So demand of the highway depends upon travel time. Okay. So when we are calculating the demand for a highway which connects point A to B, that comes from travel time. Okay. So these are called as demand forecasting models. Okay, and this is where we use them. Okay, so we will continue with some more studies next time. Any questions?